हेलो फ्रेंड्स, माय नेम इज अमित जैन एंड आज हम लोग सीखने वाले हैं प्रॉपर्टीज ऑफ सिस्टम, लेकिन फॉर्मूले बेसिस पे नहीं, ट्रिक्स के बेसिस पे। सो लेट्स मैंने प्रॉपर्टीज ऑफ सिस्टम्स को 3 पार्ट्स में डिवाइड कर दिया है, ऑन द बेसिस ऑफ इनपुट बिहेवियर, सिस्टम बिहेवियर, और ऑन द बेसिस ऑफ बोथ इनपुट एज वेल एज सिस्टम बिहेवियर. So there are 6 properties of system: causality, static or dynamic, linearity, invertibility, time invariant, stability, and in the 7th part or in the 7th video we will discuss the combination of all 6 properties over a particular question. How you check all these properties in a particular question. So before that we will try to understand each property with the help of tricks in a detail. So let's proceed. Learns the basics of. We have to understand that what is input and what is a system. Say for example, yt equal to x of minus t. So here the input is which is defined inside the function of x. The input is minus t, and what is system? The system which is multiply or which is with x. Here the system is 1, which is multiplying with x of minus t. Try to understand with the second example. Yt is equal to log of xt. Here the input is xt, but the system is logarithmic. So system is doing the logarithmic of input value. The example, yt equal to sine of xt. Here the input is xt, but system is sine. Take the example as yt equal to 1 upon xt. Here the input is again xt, but system is doing the reciprocal of input. Yt equal to x square t. Input is xt, but the system is doing the square of the value. Let's take this example, yt equal to xt square. So the input is xt square and the system is 1. Same you can check with any type of output values, which is system, which is our input. I hope आपको ये चीज क्लियर हो गया होगा. तो आगे चलते हैं एक किसी प्रॉपर्टी को समझने के. और as I have defined earlier, linearity हम लोग समझेंगे on the basis of system. The box which I have defined in dashed line is a formula which says that if this formula satisfied, then the system is said to be linear. Here you need to understand 2 things. First thing is the t, here t is your system, and there are 2 inputs x1t and x2t, which is multiplying with a and b. A and b both are constant. So the same thing is as a superposition principle. Superposition principle states that if there are more than 2 sources, then the output you are taking across any branch is considered as turn on the particular source and kill the other source, find the value across the load, and same for turn on the second source, kill the first source and find the value of output across the load, and sum all the values of output so that you get the value across the load. And where a and b are constant, so I'm not going to discuss all these property or all this black box because this is a bookish formula. We are going to learn a simple tricks. So here a and b, simply I can say a linear system is that system which follows the input. It means output follows the input, or either can say the output is known as forced input. Suppose if input is 0, output must be 0. If input is multiplied with a, output is also multiplied with a. If input is sinusoidal, output must be sinusoidal. But it can change in terms of amplitude or it may be delayed. That is the property of a system. But the nature of output must be sinusoidal. If input is exponential, output is also exponential. So how you check? If you see the expression, you will find that the t is your system. And t must be of distributive nature. If t is a distributive nature, then you can say the system is said to be linear. And only you need to check one condition, which is constant. When you multiply a constant into input side, the same constant has to be multiplied at the output side by providing the input only. And this is known as homogeneity. But we are considering only with the help of if system is distributive, 99% say you can say this is the output is said to be linear. So let's try to understand with the help of some questions. Uh, in these in this particular slide you have around 18 to 19 questions, but check only the system first. Say for example, if system is square, so obviously you know that square is not a distributive property. A plus b whole square is never said that a square plus b square, so it is a non-linear. Say for example, trigonometric functions of any input, so trigonometric function is not a distributive function. Say for example, exponential of xt, exponential also is not a distributive function. Log of xt is also not a distributive function. Or you can say under root of xt, it is also not a distributive function. Under root is not a distributive function. You need to check only system. Say for example, if I check yt equal to sin t into xt, here sin t is your multiplier, and as we know that multiplier is a distributive function. So sin t into xt is a linear system. Differentiation of xt, so differentiation is your system, so differentiation is of distributive nature, so it is a linear system. Minus infinity to t, that is integral of x tau deta. Integral, as we know, is a distributive system, so the system is said to be linear. Now see the expression yt equal to xt plus xt minus 1 and comma t is greater than equal to 0. Here you can say the output is a sum of two input signals. One is the original form and second one is the delayed form. But the limit is defined only for t. So here the system is not enrolling with the limits. But you can say the system is only multiplier, that is 1. So you can directly say that 1 is a multiplier which is a distributive in nature. The system is said to be linear. Same for yt equal to xt plus xt minus 1 comma xt greater than equal to 0. Here you can say the system limits defined depends on greater than equal to 0. So when you give two inputs to system whose total is greater than equal to 0, it is not necessary that individual be greater than equal to 0. So thus I can say yt equal to xt plus xt minus 1 comma xt greater than equal to 0 is a non-linear system. Say for yt equal to xt minus 1 plus 3, as I told earlier, input is 0, output is 0, but if you kill the input, the output is plus 3. So output is depending upon the internal storage or internal energies of the system. So it is not a linear, it is a non-linear. Yt equal to x of sin t. Here you can say the sin t, x of sin t is only a input. So here is your system is 1, it is a multiplier, so system is said to be linear. Let's take the example yt equal to e1 of xt. So how would you write e1? xt plus x of minus t divided by 2. So xt or x minus t both are your input. What is system? System is only the adding both the value and multiplied with 2, half. So half is a distributive property, multiplier is a distributive property, so I can write e1 of xt is a linear system. We need to check for this exception, yt equal to real part of xt. So let's take an example. 3 plus iota 4, what is the real part of this input? Answer is 3. So when I multiply with this input, let's say with a parameter, let's say j. So what is the expression become? Here your system is real. Expression become 3j minus 4, and what is the real part is minus 4. And same for if you take out the real part of 3 plus iota 4, iota j4 or 3 plus iota 4, answer is if you take the real, you will get 3. And if you multiply j at the end of the system, you will get 3j, which is not equal to minus 4. So I can say yt equal to real part of xt is not a linear system. आई होप आपको समझ में आ गया होगा. लीनियरिटी के लिए सिर्फ आप सिस्टम चेक कीजिए. अगर सिस्टम डिस्ट्रीब्यूटिव है तो यू कैन डायरेक्टली राइट द सिस्टम इज सेड टू बी लीनियर. Simple. Is all for this lecture. In the next lecture we will see how we check time invariant C or time invariant nature of a system. Thank you.